Hello there, welcome to Horizons Across. Today we will talk about basic number system. Now I know it sounds very basic as it says in the name itself, but it has way more complex topics than you think. So stop playing with your mask and let's get going. So have you ever wondered why is 9 the highest single digit in our basic number system? Now, the answer to that is that a basic number system is a decimal number system, which is nothing but base 10. Now, another question pops in your mind. Why is it called base 10 when the highest value is 9? Well, hey, don't worry, it's okay. That's because 0 is also included. So that we end our video. Hope you liked it and bye-bye. Sike! We've got a lot of stuff to do. For instance, converting base 10 numericals to base 2. Again, it does not sound cool, but it is. Now what is this base 2 you ask? Earlier, you told me that there's base 10, which is our basic numerical system. Now what is base 2? Bruh. How about you tell me? If base 10 has all the numbers from 0 to 9, then what will base 2 have? If your answer was 0 and 1, well done, you understood the concept. Now comes the part when I teach you how to convert a number in a particular base to another number in another base. First, we'll be learning how to convert numbers in base 10 to some different base. There are typically two ways of doing it, and I'll teach you both of them. One of them is tedious and the other one is easier. So we will begin with the difficult one. To convert a number from base alpha to base 10, we need to write it in the form of alpha raised to 0 into a1 plus alpha raised to 1 into a2 plus alpha raised to 2 into a3 and so on till alpha raised to n minus 1 into an, where a1, a2 and so on till an are the digits of the number in base alpha. Now let's try solving it with an example. Let's suppose we have a number 2102 in base 3 and I want to convert it to base 10. By using the formula, we can compute the number in base 10. The 2, which is the first digit on the left hand side, will be a4. The second digit, that is 1, would be a3, the 0 would be a2 and the last one, that is 2, again it would be a1. The value of alpha would be 3 because it's the base. Now all we have to do is put the values in the right place. Boom! And when you do the math, you'll get the value as 65 in base 10. This paradox here is converting a number in some different base to base 10. To convert a number in base 10 to another number that is in base alpha, you need to equate the two numbers, as in the number in base 10 is equal to alpha raised to 0 into a1 and so on. And for solving through this method, you have to apply more efforts, which will tell you while solving the question. So let's take the same numbers, except this time we'll be converting from base 10 to base 3. The question would be convert 65 base 10 to base 3. So we equate the values. 65 is equal to alpha raised to 0 into a1 and so on till alpha raised to 3 into a4. Now how did I come to know the number of digits in the third base? The highest power of 3 that is closer to 65 is 27, which is 3 raised to 3. I cannot take 3 raised to 4, that is 81, because 81 is simply greater than 65 and it cannot be a 5-digit number. Now that we know that the highest exponent of alpha would be 3, that means we have 4 digits because alpha raised to n minus 1 into an, where n is equal to 4 and n minus 1 is equal to 3. Now all we have to do is use the trial and error method for determining the values of a1, a2, a3 and a4. Now the trick is to use the highest possible value that will take us closer to 65. We'll start with the alpha, that is the highest part, which in this case is 3 raised to 3. Over here 3 raised to 3 is 27, and if I take the value of a4 as 1, it'll give me a 27, but if I take the value as 2, it will bring me closer to 65. That will be 2 into 27, that'll give me 54. Now we're left with 11, and the next number we have is 9. The closest we can get to 11 is by multiplying it by 1, that is 9. So now there's 2 remaining. Now a3 into alpha raised to 1, that is a3 into 3 raised to 1, should be closer to 2, but the closest we can go to 2 is 0, because if we take the value as 1, it would be greater than 2, which we do not want. So we'll multiply by 0. That means the value of a2 would be 0. Now in the end, we have alpha raised to 0, that is 3 raised to 0. into A1, and the closest we can go to 2 is 2 because all we have to do is multiply 2 into 1. So the value of A1 would be 2, and therefore we get the answer as 2102. And voila, that's how you can convert a number in base 10 to a number in base 3 or any other number if you use the formula right. Fun fact, binary, a language that the computer understands, is basically a basic numerical system of base 2 because it's just 0 and 1. Now comes the second method, which is easier. All you have to do in this method is keep on dividing a number with the base number, that is alpha, till you reach a point where it's no longer divisible. Then write all the remainders from the bottom to top from left to right. And the number which you obtain, it will be in base 3. Let's try it out then. I have the number 65 and I want to convert it to base 3. So I will divide the number 65 by 3. The question I get will be 21. And the remainder would be 2 because 21 times 3 gives me 63. Now I'll divide 21 by 3. That means it'll give me 0 remainder and the quotient would be 7. Divide this 7 by 3. I'll get 1 as a remainder and 2 as quotient. Now as you can see, 2 is no longer divisible by 3. Now we'll start writing our remainders from bottom to top. That is 2, 1, 0 and 2. And those gates. We have converted 65 in base 10 to base 3, which is 2102. And with that, we have come to the end of this video. Hope you enjoyed it and peace out boys and girls.